I'm super excited to introduce Brandon Reville from Code.org, the creators of the Hour of Code. They have done a tremendous amount to drive programming and education into schools, put together over 198,000 events in a single week. And if I recall correctly, it was tens of millions of sessions that you guys have driven across the country. Brendan was the guy responsible for delivering the Star Wars coding tutorial, which talk about your awesome IPs. Before Code.org, he was a member of the Xbox team, and he's going to tell us some super interesting stuff about what delivering that Star Wars tutorial looked like.
Thanks.
On the challenge.
Hi, everybody. Has anybody here heard of Code.org before, or the Hour of Code? I see a few hands. Great. Well, I'm Brendan. I work at Code.org as a software engineer, and my job was to deliver the Star Wars tutorial for last year's Hour of Code. A moment to talk about Code.org. We're a 3-year-old nonprofit organization. We have a simple mission, which is that every student in every school should have the opportunity to learn computer science. Our founder made a YouTube video which went kind of viral. I think it's 12+ million views right now. And once the video came out, he asked, well, what do I actually need to do to bring computer science to students? And there are a few things that needed to be done. The Hour of Code is one ingredient in the bigger set of things that Code.org does. So I arrived there 2.5 years ago when there were about 15 people. We're now heading for 60 people, based primarily out of Seattle, but we have also an education team distributed around the US. So what does Code.org actually do? Well, once a year we do the Hour of Code, which is a big online event that occurs really all around the world. And the idea is that classrooms around the world, students have the chance to do just 1 hour of coding as an introductory activity to realize they really enjoy it. And I'll talk more about the goals behind the Hour of Code a bit later as well. We also actually build, the Hour of Code is famous but not the most important thing we do. We actually build a full K-12 curriculum, and we have some courses already released and others in progress right now. And the idea is, as well as partnering with other organizations that build a full K-12 curriculum, we're actually providing a curriculum ourselves that covers it's an entire continuous flow all the way through. It's all free, open source, available online for any student, any teacher, and student, parent to use around the world. We also train teachers. This summer we've been doing a large amount of in-person events all around the US in which we train both teachers and we train affiliates who will in turn train teachers. We've done big contracts before with school districts around the US, and we're transitioning to an affiliate model so we can scale this up to train literally tens and hundreds of thousands of teachers around the US. Finally, we do advocacy both at the state and federal level. It often happens that in certain states, computer science doesn't even count as a graduating credit, or there's not very much funding available for computer science, and so we work with states especially to actually move the needle on those things, and we've been fairly successful in doing that as well. The Hour of Code, we had our 3rd annual Hour of Code last December. This map was from before the event actually occurred, and we had over 198,000 real-world events signed up around the world. These were often teachers with classrooms in schools, but also after-school events, community organizations, things like that. And come Monday morning of the Hour of Code, we get an incredible spike of traffic to our website as we serve up both our own tutorials and also a showcase of a whole bunch of third-party tutorials that are really awesome as well, that we really enjoy showcasing and sending our users to. This photo montage tries to capture some of the excitement of the Hour of Code. It's a lot of kids on laptops, on PCs and Macs, on iPads and mobile devices, often trying programming for the first time in a structured activity in which they work through a small tutorial. Some kids will work through several tutorials. They print out their certificates at the end of the lesson, and it's a funny feature that we added at the very last minute before the first Hour of Code, and we know we've had an incredible number of certificates printed all over the world and pasted up on classroom walls. I'm going to dive in a little bit to the Star Wars tutorial that we built, but along the way I'm going to talk about how it ties into our bigger design goals and our bigger aspirations for the Hour of Code. For this tutorial, we partnered with Disney the year before on a Frozen tutorial, and it went very well. And this year we had the opportunity to build a tutorial using Star Wars, and so we decided to build a whole new tutorial. We actually delivered 2 flavors. We always do block programming, which I'll talk about, because we never want kids to battle with syntax, with where does the parentheses go, where do commas go. So we like to offer this block programming experience. But we also did offer a JavaScript experience for the first time, in which kids could type real JavaScript and actually flip back, and using this great open source project we found, they can flip back and forth between blocks and real JavaScript for more advanced users. And we saw some slight behavioral differences between the 2 groups here. Has anybody seen a Code.org tutorial before? Well, I'm going to just talk briefly about what we put on the screen. And we do this for all of our tutorials, all the way from K through 12 for all of our curriculum. We always give kids instructions. Very important to give them some instructions on what to do, just to give them a goal for the level. And with Star Wars, we had the opportunity for Rey and Princess Leia to actually speak directly to the player. So we have some instructions. We have a gameplay area, which is where the action all occurs, and that's kind of a simulation or a sandbox that the student's code runs in. We have some controls, both for running and resetting the simulation and also for steering characters around. We know we're going to run on touch devices as well as desktops, and so we need to offer some UI for doing some steering. Every tutorial has a palette of blocks, and in this case, we over every level of the tutorial, we adjusted this palette of blocks as we introduced new concepts, and we thought a lot about that progression. We have our workspace in which students construct their code. Often our tutorials, the early ones, are a bit like the old turtle where you steer a character around on the screen, move forward, turn left. For the Star Wars tutorial, we took things a little bit more advanced and started introducing event-driven coding, and you can see here the students actually, when the program runs, they do some work. When they touch a certain character, they do some other work. And so we've used this block paradigm for event programming. Something super important that is very relevant actually to classrooms is this little set of dots up the top of the screen here. When you're in a classroom and you have a whole bunch of students working their way through a tutorial, you want to try to keep track of how the classroom is progressing, where everybody's up to. Having these little colored dots across the top works out really well, because at a glance you can walk along a row of students and just get a feel for where everybody is up to and which levels they might have skipped, which ones they've struggled with, and which ones they've succeeded in. And so this little set of dots permeates all of our curriculum, and it's turned out to be very useful. I'm going to show, I don't know how the audio is going to work here, but I was going to show just a few levels from the progression, just to give an idea of how we staged the experience for the Star Wars tutorial. We have 15 levels in this tutorial, and the first 6 are actually the more traditional steering a character around, and we got to use BB-8 and Rey for this progression. This is the second level of the tutorial, and you see that it's really simple at this point. Oh, look at that music. We can turn it down a bit. So here we have BB-8, we have some scrap metal that BB-8 needs to collect. Did that work? Okay, great. So the first level, all we're trying to do is build kids' confidence. At this point, we don't want to give anybody an unpleasant or scary experience. We want to just make sure kids are successful and have a small victory. And really, we want every level of this tutorial to be a series of small victories that build on previous work. And so here we had BB-8 collecting the scrap metal, making it to the end, and the student has learnt some very basic concepts. If we drive along a few levels later, you'll find out we've already started building a more complex level, and we'll watch BB-8 again, pretty much do the same thing. This is pretty much as far as we take this type of level. We do 6 levels of this very basic steering BB-8 around. A couple things of note here. You'll see that I dropped the proper solution in the first time. And this happens a lot, but students so often don't succeed the first time. And we never want to punish them for experimenting and making mistakes, but we want to build a very easy system for them to actually drive around, or make a bunch of attempts. I think we can always do a better job of actually modeling this behavior in students and actually showing we do videos with celebrities along the way and good role models for students. And I think we could actually do a somewhat better job of modeling failure in these videos and showing famous, skilled people struggle as they try and write this code. And so it's very important for kids not to be punished as they make their attempts on solving a problem, but more just get a chance to iterate fast and deliver a successful result. We also debated, we had these bandit characters, and at first we stuck them over the very edges. We didn't want kids to be scared, but we actually never got feedback that kids were scared, and actually they gravitated towards having an element of danger in the scene. And so we actually tucked in these bandits right near BB-8's path, and nobody seems to have minded that. Kind of surprised me a little bit. I'm going to take a pause here from the actual tutorial just to talk about some of the design goals that we had very early on as we thought about what we were going to build. Well, for everything we build for Hour of Code in particular, it's about being the student's first coding experience. That means they're starting from nothing. We want to get them to a good point by the end of this hour, but we want to make sure it's a nice smooth curve with not too many pain points along the way. Like I said, 1 hour. We want to make sure that this tutorial can actually be finished in an hour. And in a classroom setting, of course, there's setup, tear down, bringing devices in, getting kids all set up. So you actually want to think more about something like 45 minutes probably in our average case. We love using level progressions. A lot of other educational tools, like I think Blockly, it's a fantastic sandbox, but you often need a teacher who is quite skilled in structuring lessons and structuring progressions for students. We've always, from the earliest days with Hour of Code and with our materials in general, have used progressions in which we structure level by level. It's game-like, it's fun and familiar to kids, and it lets us be very deliberate about how we structure the lesson for them. And that means teachers don't have to be on top of what every student in the classroom is up to. It means they can let the kids run through the progression which we've built for them. Broad appeal is very important for us for a couple reasons. We have a very big focus on diversity and equity. We want to make sure that girls and minorities feel very empowered. And that means choosing properties that have very broad appeal. We did a great Minecraft tutorial as well that was very popular with Microsoft. And we want to make sure that, in this case with Star Wars, it was great we had Princess Leia and Rey actually directing the droids to success. It means also in the game content you choose. You know, for our case, there was no weapons. We want to be in schools. No weapons, no shooting, no violence. The main interaction we have between characters is just a very smooth vanish. And so it's very important to think about both the experience and the content to make sure it has the right broad appeal. We love having shareable games. We make sure that when students finish their final level, it's a sandbox where they build their own game. There's a few things we let them do. We let them send it to their phone and actually set it up as a little embedded web app on their phone. We think kids love being able to show their game on a phone. Let them copy the link, send it to their parents, send it to their friends, and actually when someone receives it, they can view the source code and then start remixing the game and building on top of it. So we're really big on making sure that kids, when they finish, especially in a classroom where they probably don't own that computer, they have a chance to take their work and share it afterwards. Finally, once you're in a school, you will come across an incredibly broad array of hardware and software, and it's very important for us, especially as part of our diversity and equity angle, is to make sure we run on the broadest array of devices as possible. And that means mobile devices, desktops, laptops, very, very different screen resolutions, very old small CRTs all the way up to nice big monitors, and very old browsers and operating systems. And we've done a lot of work on broad compatibility testing, a very big suite of automated testing to make sure we're compatible across a lot of devices. I was going to jump ahead to show a couple more levels from the tutorial. We made a big bet on this tutorial to actually start teaching a bit more something like game programming with interaction and event-driven programming. And so Puzzle 8 is one of the very first levels where we're teaching students about events and how they can start steering a character on a screen. So you'll see in this case, I make R2-D2 walk. So pretty standard stuff, but hopefully for kids an exciting first experience in steering a character. We actually did something interesting here. We realized, well, we like teaching students about matching movements to steering, but we didn't want them to have to do the same thing every level as they kept going, because they'd be duplicating the same actions over and over again. And so we actually hid that functionality. Once we taught it, we decided it's okay for them to know it's there. We'll bring it back for the sandbox at the very end, but we'll move on to teach some other concepts. In this level, we're starting to actually get kids to think about events as they start doing game actions. So they'll have to reach some Rebel pilots, get some points, but you'll notice they'll actually have to be thoughtful about how many points they add to solve the puzzle. So we kind of layered in a little bit of math and a little bit of fun math, just to make sure our students can get through the level. So that's how we got enough points. One thing that wasn't shown here is we actually built a fairly complicated hinting system, because we knew students would usually finish the puzzle first by getting 100 points each time. We actually detect a lot of these mistakes and give very customized error messages, and we had a very large conditional messaging system with tons of hints like that. I'll show one last level where we start building some more game ingredients. Turns out that level's actually difficult to play, and I've actually struggled a few times in actually finishing the level, getting the right number of points, not losing the wrong number of points. But we actually give a hint down the very bottom and point out to the student there is another creature, and you could throw some extra points in there. And we're actually telling kids, in this case, there's kind of a cheat you can build. And it might seem controversial, but we actually realized that kids, once they realize they can start playing with code themselves and implementing a cheat, they're actually learning a lot more, and they're actually demonstrating some pretty strong competencies around this programming, what programming enables them to do. And so we actually encourage, and later on you'll see how we actually think it's great when kids think they've exploited our system a little bit. They haven't really, but it's a great demonstration of going deep into what coding lets them do. So we landed this tutorial. It was about 6 months of work, and it was a pretty intense experience building it with a partner and getting it ready in time for Hour of Code. There are a few things we did to land it what we hoped was successfully. We did a lot of classroom testing. We would take our betas into real classrooms, and it's amazing how much you learn just from 30 kids in a room for 45 minutes. So we did great classroom testing. One thing we found useful was to bring in a few other people from our team to act as observers to spread out through the room and take notes. We also asked kids to give us their notes on paper, and then we'd collect them all afterwards and look through what kids told us on paper, not just verbally. And it was invaluable. And every time we did a round of classroom testing, we would come back, we would shuffle our level order, we'd add things, remove things, and we really iterated until we were confident we had a progression that was successful. Analytics, we of course have Google Analytics, and we analyze how much time is spent in each level and success rates through each level. And it's funny watching students as they get near the end of the tutorial jumping towards the sandbox level at the end when they're ready, and our more advanced students were jumping a little bit earlier, and we think that's just another sign of success. If they want to jump into a sandbox and start making things right away, more power to them. We actually just asked our users to rate the fun of the levels. We have a thing we call the funometer, the closing dialogue of a level. We have a little heart, and they tell us if they like a level or not. And it turns out we rank all of our different tutorials by funometer, just internally for curiosity, and we can dive into every level, and we can actually understand which levels are really fun and highly rated and which ones aren't. So it's kind of amazing just to ask your own users what they like or don't like. You learn an incredible amount. And finally, as I mentioned before, iteration. In each case, whenever we had new data, we really iterated on our design and our progression to improve and to make sure we were building something successful for students. So we ended up with 15 levels. We have some sandy levels with BB-8, and we move into a range of other backgrounds. And the content we received from Disney and LucasFilm meant that we were able to do various combinations of changing backgrounds and scenery and creatures. And we actually had to build something that could take anything that the students throw at it. It was up to the student to build code to actually change what was shown. We ended up with for an hour-long tutorial, it's actually quite a lot of concepts to have given kids. We gave them, by the time they end the tutorial, they end up with the palette of events on the left and the set of commands on the right. And they can build combinations of all of these. So they could build events and command combinations that we hadn't even thought of before to build interesting little gameplay experiences. Well, were we successful? This is a blink and you can miss it kind of slide because these images, these animations won't loop. But here are some of the things we ended up teaching our students. First, we taught them that if you reach a rebel pilot, you can make a whole bunch of stormtroopers appear. These are things that kids discovered they could do as they went. We taught them that if they reach C-3PO, they can actually say they've won a game, and they can actually build games that you can win or lose. The final screen, kids decided that when you touch one creature, you could generate another 10, and when you touched all 10 of them, you could generate more. Kids would put up their hands and say, look, I hacked your system. They were so proud, and here it goes, just total chaos. But it was fantastic. They didn't really hack our system. We knew they were going to do this, and we just absolutely loved seeing kids in 1 hour decided they had figured out how to break a system, but actually code a really interesting chaining event system. That's what we built. Thank you. You can play the tutorial at code.org/Star Wars. Everything we do is open source on GitHub, so you can actually go take a look at the source code. And I'm Brendan, and thank you very much.
I'm just curious on the Funometer, what separated the levels that scored high and the levels that scored low? Was there?
It's a really good question. I think if you give them a bad experience, it's a level that people aren't even figuring out how to solve, it goes low. I'll tell one interesting thing that came up. We noticed in the Minecraft tutorial, they did a really nice job adding polish. And I remember there was one level where you build, I think, a track, and you build a track, and then you finish building a track, and then an animation of a train plays along it. It was a little delightful, emergent behavior that came out of their work, and I remember that got rated very highly. And we think, giving kids a good experience that they can succeed, but then rewarding them with a bit of extra delight seemed to work out really well.
Was there a difference in the interest and feedback between boys and girls at all?
That's a good question. I don't know if we pivoted between the two. I worked on the Frozen tutorial the year before, and I do think we do see, in some cases, classrooms gravitate, girls go towards Frozen and maybe boys go towards Star Wars. But I think we really tried to build something that was appealing. We tried not to partition at all. We really tried to keep, to make sure every tutorial appeals to everybody. In this tutorial, I don't remember seeing specific data that varied between the genders. Good question.
Awesome. Thank you so much, Brendan. I know we've cut questions a little bit short. If folks have questions, can they meet you in the hallway?
Yeah, totally. Yeah.
Awesome. Thank you so much.
Thanks.